Hello and welcome to another IB Mathematics video. In this video we're going to be talking about data, what data is and the difference between data and information. Mainly data can be anything. Anything has data. A big list of numbers is data, or just looking out your window you can see a lot of trees. Well, perhaps the height or the number of leaves per tree is data. However, not every time you have data, you have information, because information is when you can understand the data. And not always you look at data and it has meaning for you. You might have a huge list of numbers that mean nothing to you, but when somebody tells you, hey, these are the different weights of cars, and this is the average of these three brands, you can see that, oh wow, Honda is heavier than Suzuki. Well, that's information. And that's the difference between data and information. In information, you understand what you have. Data can just be a list. So in statistics, we turn data into information, and that's what we're going to be doing. But to do so, we have to understand the different types of data. So here's a very simple example. You have the colors of autumn leaves in Massachusetts, and for example the height of the Boston Celtics basketball team. Now, how are these different? Well, look at the different data we have. We have red, orange, yellow, etc. 2.10, 2.04, 2.01, 2.12. Easy to see. What is the difference? What are the different types of data? Well, we have words, or we have numbers. Another way of saying this is we have quantities or we have qualities. And that's what we call quantitative data and qualitative data. Remember the difference. Qualitative shows qualities. Quantitative shows quantities. So numbers goes for quantitative and words goes for qualitative. We're mainly going to be dealing in this course with quantitative data. It does not mean that qualitative is any less important. It's just part of the syllabus. And we deal with quantitative data because it's actually easier to deal with quantitative data. It makes more sense from a mathematical point of view because you're adding numbers, subtracting, dividing, and it's harder to do that with words. So this is an introductory course. This is your first steps in statistics, and that's why we're using quantitative data. Also, there are different types of quantitative data, and this is less evident to see. So, for example, if you had the height of the Boston Celtics basketball team and the shoe sizes of students in a class, what is the difference between this kind of data and this kind of data? Well, one, we say it's discrete because it can only take some values. We have 42, 41.5, 44, 38. But imagine somebody comes up to you and says, hey, my shoe size is 34.78. What would you think? You think that, well, it probably means 35 because there's no shoe size 34.78. That's what happens. There's a limited amount of possibilities for what data can be, for the values data can have. It's different with the measurement, and that's what we call continuous data. And this is a very important difference because you could have something in between. You could always have somebody who is in between this height and this height, or even heights that are very close to each other. You can have somebody between this height and this side. You could have somebody that's exactly 2 meters tall, and that's possible. Or even between these two, because you could have something that's 2.015. There's always a possibility that there is a value between two different values, and that's what continuous data is like. Discrete, limited number of possible values data can have. It can be a 1 or 2 or 3 or 4, but no 5, no 2.5, that's discrete data. Continuous, anything between 0 and 10,000. Anything in between works. That's continuous data. So now you have the different types of data. We have quantitative and qualitative, and within quantitative we have discrete and continuous. Now we're going to be looking at ways of collecting data. So let's be practical about it. Suppose you want to do a statistical study on people's income in Majadahonda, or the names of students in a class, or people's religious practices in Europe. How would you gather the data? You could, of course, just ask absolutely everybody, but think about it. You have different populations for these problems. If the names of the students of the class we have, how many people are in the class? Suppose there's only 28 people. It's easier to deal with this population than it is to deal with the population of Majadahonda, or dealing with the population in Europe. So the population, which is the number of people or elements we're studying, is a very important factor. And depending on how high the population is, it's going to be different how hard it is to ask everyone. And that's why we take samples. Sometimes we can ask everybody, but most of the times we can't. It's quite hard or very difficult or practically impossible. Can you imagine trying to ask everyone in Europe? Well, that would be impossible. So what we do is we choose a sample. We ask only some people. Maybe 1,000, maybe 2,000, doesn't matter, maybe 100, maybe 10, maybe 10,000. It's not really important how much exactly. The fact is we're not asking everybody, we're asking a part of the population. So how do we take a sample? Well, there are different types of samples. This is different. Before we had different types of data, now we have different types of samples. So let's keep with this example, religious practices in Europe. There's 420 million people in Europe. And suppose somebody tells you, hey, I'm going to ask 1,000 people in each country from different cities, rural areas, etc. And somebody says, I'm just going to go to Poland, Italy, and Spain and ask. Well, this is representative because Europe has many different countries, and you would want to go to Sweden, you would want to go to Finland, you want to go to Denmark, you want to go to every country. You want to have a representative sample so that you're trying to make a sample so that everybody is represented. When it's not the case, when you haven't done that, we call it a biased sample. This is like cheating. This is like doing things wrong. These are biased samples, so we have to take care that samples are taken correctly and they are representative samples. Other different types of samples are random samples. This is when we ask random people because we can't, there's a point where you can't classify all the different types of people there are and say I'm going to ask young people, old people, young and from a rich background people, old from a rich background, old people, or women or men, or different ethnicities. Also, there's too many different variations, so we just do random. So anything can show up, and everybody in the population has an equal chance of being asked. If we don't do it random, again, we have a biased sample, and this is where people are cheating. This is when people say, okay, you know what, I'm going to ask about religious practice in Europe, I'm just going to ask Sunday morning. And guess what? Well, what happens Sunday morning? Well, there's church. So people who go to church are going to be the people who are more often asked. And people who don't go to church might not be out in the street. And therefore, that's a biased sample and not a random sample. So you have to understand that a random sample is a better sample than a biased sample. And those are the different types of samples that we have. So remember, you have to understand the following terms. This is what's going to be important. It's just understanding definitions on what they mean. Qualitative data, which is when we have names instead of numbers as data. Quantitative data, when we have numbers as data. Discrete, when there's a limited number of possible values the data can have. Continuous, when there is infinite amount of things in between that the values can be. Population, which is the number of elements we're studying. Sample, which is when we take a small part of that population to study everything. A representative sample, when you try to have all different types of elements represented. Random, when we just take random and everybody has the same chance of being selected. And a bias, when we've cheated or we have done things wrong. That's what a biased sample is. Thank you very much for watching.